Okay, so as I mentioned just before the break, what we want to do here, we observe series like that. We get that it's published data or it's data that we don't collect or generate ourselves, but now we want to match that kind of closest to a standard statistical process. So this is an AR1 process where AR stands for autoregressive, and this is typically, I mean, I have indeed generated this process, but it looks very similar to a series that we observe, the all share price index, but taking the returns, the growth of that, can potentially look like this. And I've generated, I actually did not generate this. This is already downloaded from the thread. My brain died during the tea time. This is actually the all share index, the growth rate on the previous period, but that looks very much like a series if I would generate it with using a seed value and a random generator instead of that, and put a value there that is not 1, anything smaller than 1, 0.9, 0.8, 0.5, but not 0, because that will be a flat line. Oh no, it wouldn't be, but the random generator will cause some variation there. So if I see a series like that, I will say maybe it looks most like a series generated like this. And we will generate those series in a minute and confirm that. Why is this thing now not? Maybe the battery. Let me just see. Oh, it's alive again. This I also downloaded from the thread, and this is monthly retail trade figures, seasonally adjusted. But if I see something like that, I immediately think it resembles a series that I can generate putting an alpha of 1 there. Except this will probably not happen if in generated series. That was the impact of COVID on retail sales, retail trade, for a very small period, because this is high frequency. It's probably monthly. I think there was 1 month that very negatively impacted trade. The CPI, does that look like a... It's not really a linear trend. We can see that one has an exponential trend. So that looks like a series that was generated with an alpha bigger than 1. But question mark, we have to, that's just our expectation, our speculation. But those are the easy ones. But if we see a series like this, the 3-month treasury bill rate, the risk-free interest rate, this is really the trend starting here in the 70s, with almost no inflation, so the interest rates were also low. But then, after the oil price shocks, interest rates had to be adjusted upwards in order to force people to spend less, and in an attempt to bring inflation down. And we know that most of our trading partners, this is not the inflation itself, these are the interest rates that, it's not the policy rate, but the money market rate will respond to the treasury bill rate, will respond to the inflation. And we know that our trading partners, the inflation went up to just about 12% the US, but then quickly came down again. Our inflation went up to around 18%, and you can see here our interest rates went up to above 20%, and stayed high for a while. And as soon as we move into the inflation targeting era, interest rates also came down. But this is now our reality. And the question is that series stationary or non-stationary? None. So this is where sometimes unitary tests don't get it right, where we have to put a little bit of our own intuition. This is where you sometimes see the picture, the computer doesn't have a brain, use your own. So we use the tests for the easy stuff, and when it gets difficult, we have to put a dose of common sense knowledge as well. So you can almost argue, in the bigger scheme of things, this looks like a mean reverting process, but on the other hand, it looks like an upward trend, a downward trend, and a little bit that appears to behave like a stationary process. But overall, my guess would be a unitary test would find this non-stationary. But also, a random walk can indeed drift like this. How about quarterly South African electricity production? Almost, it looks like there's this underlying deterministic trend, right? Also, perhaps, maybe, some stochastic behavior, and then over and above that, we have a structural break around 2008, 2009. And I actually checked this the other day, so my expectation was that, what would you say if you now look at it? Where would that line go? Up, straight, further down?
Let's spike, then push up again.
That was my expectation as well. It's going further down. So I don't know. I'm thinking, is it more people using solar? The street lights are not working. How do we? Our lights are on.
Yes, but there is this behavior when it comes to graph. For every graph that we have, there's this pattern that is tend to create over time. If you observe it critically, you're going to see, you know what, this thing they're doing one and the same thing over and over again. For example, the one that you have just showed us a few minutes ago, I think it was unrelated. It's still going to go up, then pull back again immediately when this touches that very same level. It seems as if like there are this system that they are using. I don't know who's creating these things. Like everything behaves the same. For example, if for every 10 years they'll go down, go up, go down, go up. There's always, like
law of physics. What goes up must come down.
Like you can check the pattern. If you can take the financial textbook and then you compare it with a certain graph, maybe of a certain stock, you'll see this pattern. Then if maybe you take whatever textbook that has graph, then if you try and sit down and checking this graph, they have similarities. They create certain patterns, whether they are going up or going down. The pattern is normally like W and V1 and V2 and M, pull back, A1, A2, consolidate a little bit, pull back and push, retest, pull back, all those movements. If you sit down and check, you notice that there's always. So this is how I would take that statement. Thank you.
Now you've confused me. It sounds like conspiracy.
I'm referring to the graph that come downs, go up, come downs. They're creating a similar pattern.
Remember, but economics, we have business cycles, and many of those things are leading or lagging. Yes, we have the Reserve Bank representative.
No, I wanted to say sometimes it's important to look at certain time periods. So it'll be like pre-GFC, post-GFC averages.
Okay.
And then you compare what you're currently seeing in like post-COVID and seeing are things reverting back to pre-COVID levels or post-GFC levels. Like certain time, like you said, like, or maybe now there's a new trend post-COVID because fundamentals have changed entirely. So like we were talking about commodity prices. So there's a time just post-COVID where rhodium and palladium prices were going like really high. And a lot of people were thinking they would stay elevated for long, but some more experienced economists were like, well, no, they're going to go back to pre-COVID levels because that's just what they did at a certain time period as well. They go crazy when something extraordinary happens and then they come back down. So,
Yeah, sometimes bubbles build up in markets, whether it's the housing market, whether it's stock market, and
But they always come back and retest. For example, they just zone flip in this movement. There's always zone flips, you know. If they will pull back maybe level 100, they'll go up, come back and retest. For example, I'm looking at that line. You see that line?
which line? This one.
Yeah, where it has tails, a zone flipping check on the left hand side, and then it goes up, pull back, and goes up again. In every chart that you do, this is what normally happens.
But just from like just observational and just being a human being, aside from being an economist, just being like a regular person in the economy, I mean, logically, it's quarterly production. I mean, technically, the infrastructure is failing, so isn't that good enough explanation to say that it's going to get worse? Like, you know, like the infrastructure is technically.
Yeah, I mean that's a research question on its own. We had a quite a period of quite severe load shedding, and now it seems that they managed to catch up again with production. But maybe in the meantime, many households and businesses have moved to greener alternatives. And now we need to produce less and still keep the lights on. But also if you drive around at night, have you noticed how many street lights are not working? We save a lot.
That's political.
Maybe crime is up, but
Sure.
we have enough to power our desk lamp if you study at night. Yeah, so that is probably a series with a trend in a deterministic trend, that T is actually time, but with a break. And it's possible that maybe if it goes flat now, it goes sort of flat, but still slightly down. I've looked it up the other day. So that's just a few examples, but as we mentioned, there are many to look at. But the principle is that now we just want to use a few tools to effectively, if those were the variables going into our model, for argument's sake, we have to take each of those series and basically put them, categorize them. We will have 2 bags, 2 boxes, 2 whatever, 2 holders. One has a label stationary and one has a label non-stationary. So each of those series, you can just put in one of those boxes. Stationary I0 integrated of order 0 or I1 integrated of order 1. Non-stationary. And in the non-stationary box, we have a divide. Non-stationary I1, non-stationary I2. So whatever we do now is to take electricity generation, GDP, retail sales, and when we're done, we have to assign a label to each of them, and that will be so if our model is going to be Y, X1 and X2. So for each of that, we have to tick a box. And the box is stationary or non-stationary. And you can only tick one. You cannot tick two. And if it is stationary, we know that a stationary series, we will now see why we say that series is integrated of order 0. If we tick the non-stationary box, if we on this side, then here we have to tick one box. Is it I1 or is it I2? So if we tick a box here, then we have to tick one box there. It will less like, I cannot wipe it with my finger. But never mind, it will likely be I1. If I tick this box, I will not tick any box on this side. And that is now our job, using a whole lot of technical procedures to get that done. So just a little bit of the tools that we need is 2 operators, a lag operator, and a difference operator. I mean, we know it already. We just want to, just like lawyers use a few Latin words, we just want to formalize it a little bit. So the lag operator, if we put an L before X, actually there is a 1 superscript there as well. That means X lagged by 1 period. So if we say this is equal to L, it's not power in this case. It's the second lag, so it's the lag of the lag. So it's a lag of xt minus 1, so it's actually xt minus 2. We don't really need what's in front here. This is what matters. General L, I want to say L to the power k, but that's not what it is. L superscript k, xt, means xt minus k. It's just, textbooks use that to refer to, because very often we have a whole complicated lag structure up to order k. Then the difference operator, you see now we use that lag operator. So difference now mean 1 minus L. But actually if we write delta yt, all that we mean is y in period t minus y in period t minus 1. That's all we mean. But we can write it as 1 minus Lyt or yt minus Lyt, where that L means we put a minus 1 next to this t. So delta, so if you see 1 minus LYT, what does it mean? Delta YT. And so, and then a second difference is the difference of the difference. So the difference of that, and that actually is YT minus YT minus 1 minus YT minus 1 minus YT minus 2, which is YT minus 2, YT minus 1 minus YT minus 2. And that's also a reason why when we have dynamic terms, we stop interpreting the coefficient, because it can be positive function of YT, a negative function of YT minus 1, and a positive function of YT minus 2. So depending if the series are trending up or down, the coefficient can be positive or negative. And then the second difference is just the difference of the difference. And k times, we difference the series k times. So we can take a second difference. If we do it, why do I every time open this one? It's blue. It's also blue. This one is more. And at the bottom of that slide, I actually show the coding in R, eViews, and Stater. Some use a difference operator, some use dot variable or L variable. So it differs slightly across the languages. So having a difference, so we can actually generate the second difference by just applying the difference on DL cons. We can do it that way. Or we can apply the difference of the difference on L cons, ln cons. Or it can be, so that will create ln cons. That will create the, maybe I must keep that. So that will create the second difference, which is similar to doing that calculation. Type it out like that. But that is now just so that we can use it when going forward. So the definitions, and Tapelo, you can go to sleep. Yes.
After the first difference, and also the second difference, what is the implication of that in the observation?
You mean the number of observations? You lose the first two observations. Yeah, for first difference you lose 1 because it's YT minus 1. And then second difference you lose 2 observations. Okay, so if you have, but typically we will do this when we have many observations. If you only have 10 observations, you don't want to lose 2, but it's very unlikely that you will have an exponential data trend there in any case to start with. Yes.
In terms of modeling, I see most papers or books who would not demonstrate examples on a second difference in series. In
economics, you have to be careful by assuming a series is explosive. Because what are we saying? If a series goes exponential, it means that the growth rate will increase 1%, 2%, 5%, 10%, 100%, 200%. I mean, yes, hyperinflation, countries with prices with hyperinflation can be explosive, but then it's in any case difficult to model. Then it's in any case a big challenge
So in that
to
case,
build that model.
we throw the variable away. Assuming the variable is so important
Yes.
as the UI economic theory or
I guess if you have for the short run, you will have to difference it twice. But be careful, because I have reviewed papers, and then the reported order of integration for the GDP of the US is I2. What are we saying? The growth rate is a non-stationary process. The first difference. It's almost not realistic. I know this, M3 money, but if we take the log, it doesn't have that explode. But yes, here and there, occasionally, you have a series that's a little bit exponential, and including that in a model. Typically, the first literature said all variables must be the same order of integration to put it in a co-integrated model. But it developed so that we can relax that. Theoretically, we know we can't put an interest rate in the long run. We have to put it in the money demand equation as a opportunity cost of holding money. And we use the bond rate for that. Because if you don't keep your money in demand deposits and cash, you can invest it. And way back when the theory was developed, the only alternative basically was bonds. Now we have stock. You can put your money in the stock market. You can put your money in luxury goods, and not or buy bonds as alternatives to holding cash. So that bond rate represents all these asset classes. But an interest rate may potentially be stationary. Not that I say it is, but sometimes, like inflation, can be a stationary process. But we still want to put that in the long run as inflation expectations. How we think about that, adding one stationary variable into that mix doesn't change the outcome, doesn't change whether we find a co-integrated relationship. However, we cannot have a trending variable on the left-hand side and only that one stationary variable on the right-hand side. That cannot give us co-integration. We need one more, that's I1. So we need money and income, and then adding a stationary variable. And the same story, if we add a variable and it happened to be explosive in modeling one of those difficult economies, where we have periods of hyperinflation or whatever, if you have an I2 variable, to find co-integration, you will need another I2, so that those two can break down to an I1, together with the other I1s break down to a stationary result, a co-integrated result. So if all of this doesn't make sense now, we will discuss it a little bit more in detail.
Yeah, I think I've seen papers which confuse the concepts around how we should understand co-integration, because you see the author says, I found all these processes to be stationary, but they go ahead to test co-integration.
Yes, no.
To a wrong-line relationship.
Yeah.
It's really difficult to say.
Yeah.
What do you want us to believe?
And the truth is about this I2, there's also a concept like partial integration. A variable can technically be integrated of order 1.5. So somewhere between I1 and I2. But that makes life for the ordinary modeler more complicated. So what we do is we say, does it lean more towards I1 and then treat it as I1? Does it lean more to I2 and treat it as I2? So in the end, when we throw all of that in the mix, the bottom line is the residual stationary. Then we have co-integration. But before we get there, we still have to cross this bridge. Just the definitions, because now we need all of this in order to can say a variable is stationary or non-stationary. To tick those boxes, we have to look at the mean and see if the mean is constant enough to statistically a constant mean, whether we have a constant variance and the autocovariance between two periods must be, for a stationary series, it must be a constant for k periods apart to account for those potential seasonal patterns. And then the autocorrelation, we don't do the typical definitions here, like mean, variance, covariance. So the variance isn't there, but I think it follows later. So the autocorrelation between T and K. So we've seen this definition before, the covariance of the two, and below we have the product of the variances, the square root. So if this correlation approaches 1, we have a strong linear relationship, just like always. And if it's closer to 0, we have a weak relationship. So there are the formal definitions. So we can highlight this. This is kind of key. Especially the first two, a constant mu, so you can see there's no subscript t there. It's not different for different periods. For instance, if I can draw on here a little bit, so if a series is doing that, and you look at the first part of the sample, that will be the mean, and the second part, the mean will be higher. Whereas if we have a series trending like that, the mean will more or less be the same for the whole period. So there's no subscript t there. And the same with the variance. We can see here the spread, the deviation from the mean remains kind of constant. So the variance is also not a function of t. And then the covariance simply depend on k, where k can be 4 for quarterly data or 12 for monthly data, etc. So the mean and variance remain constant, and the covariance only depends on the distance. And this is what we then refer to. This is weakly stationary or covariance stationary, and this is what we understand as stationarity. So if series are not stationary, if it's non-stationary, we may end up with a spurious result. We think the variables are related, but they're actually not. That's so-called spurious result. But we have a solution. We can correct for that. Just a little bit more definitions. The white noise, it's 4:05. Let's just do the white noise, and then tomorrow we start with a random walk. That's the lady and the dog. how is a white noise process different to a stationary process? A white noise process is a stationary process. A stationary process is not necessarily a white noise process. If the series have a constant zero mean, it is a white noise process. I mean, this is constant, that E doesn't mean a whole lot. And then it also should have zero covariance. So no seasonal patterns, no specific relation K periods apart. So zero covariance, zero mean, constant variance. So, and that is what we want our residual to be. Way back, forever. Since the invention of OLS. So we want this residual to be normally IID distributed, normally and drawn from an identically drawn independently from this identical distribution, with a mean of 0 and a constant variance. And the way we're going to determine that is, if we write this in matrix notation, it means a 0 diagonal in the variance covariance structure, meaning no heteroskedasticity, and it means 0 off diagonal elements, which means no zero correlation, and normal distribution. This is how we are going to test for that. Oops. I managed to bring up that file here. So this is how we're going to test for it eventually. So all that we we know now, the properties of a stationary process, quickly give it to me.
Constant mean.
Constant mean. Constant variance.
Covariance depends on distance.
Covariance depend on the distance k between two observations. And a white noise process, zero constant mean, constant variance, zero covariance. Yeah, so white noise is a special stationary process. A growth rate can be stationary, but it's not white noise, because we can have an average growth rate of 2%. But a white noise process is like the residual term of a regression. So that's what we will. This is actually a key element. You can already make a note. If you regress y on x and the residual is a white noise process, we will say y and x co-integrated. They co-move, the distance between them stay within bounds as a constant distance. Not in absolute terms, but in range. Shall we stop here for the day?
Yeah, that's it. I'm curious. I heard you say, even, of course, that's preempting, that's coming. You said even when two variables, one is stationary, another is non-stationary. If we were to find co-integration, it would mean on the right-hand side there must be another, that's I1. Is that what?
If the y is I1 and the x is I1, it's good.
Yes.
Yeah.
If y is I1 and x is y0
We need another I1.
on the axis. So that's what the surround is saying, basically.
Otherwise, if you try and model this one as a function of this one, what will the residual look like? Big difference, getting smaller, getting bigger again. So the residual will something do something like that. The sum will be 0, but it will be not white noise.
So, can I use the test for stationarity or the white noise as some sort of replacement for integration?
Yes. The test for co-integration in the Engel-Granger literature is a unitary test on the residual. As simple as that. They just saw a few things, and boom, reach. Okay, so thank you. We'll carry on tomorrow. By tomorrow, end of the day, I want to be through with all the testing, unitary testing and co-integration testing. Then Thursday we have the ECM diagnostic testing. Ooh, it's a lot. We'll have to move fast. VAR, VEC-M, and volatility. Gauge in M. We're now going to